Sometimes we are asked to graph a function that's fairly close to one of our library of functions. One of the techniques that we can use to graph them is called a vertical stretch or compress. This change is known as a transformation. For a vertical stretch or compress, if a positive real number a is multiplied to a function y equals f of x, then the graph of the new function is y equals a times f of x. So if a is greater than 1, then the graph is stretched by a factor of a vertically, and if a is between 0 and 1, then the graph is compressed by a factor of a vertically. So we're going to write each function for the given transformation, stretched by a factor of 3 and compressed by a factor of 1/5. So our function f of x equals square root of x, we are going to stretch it by a factor of 3. So all we're going to do is we're going to multiply the front of the function by 3. So it's going to be 3 times the square root of x. And that's all there is to that. Now if we're compressing by a factor of 1/5, that means all we're going to do is multiply the front of the function by 1/5. So 1/5 square root of x. And that's how you would write out a vertical stretch or vertical compress. Let's do it again for f of x equals x squared. We're going to stretch it by a factor of 3. So f of x equals 3 times the function. And that's it. Now we're going to compress it by a factor of 1/5. So it's just going to be f of x equals 1/5 times x squared. Again, it's as simple as that. Now we have f of x equals 1 over x. So we're going to have f of x equals, and it's again stretched by a factor of 3, so 3 times 1 over x. Now we don't like to leave it this way, so we're going to kind of simplify it, and we can say this is just 3 over x. And now we're going to compress it by a factor of 1/5, so 1 over 5 times 1 over x, which again we can simplify and just say this is 1 over 5x. Last, f of x equals absolute value of x. So we're going to stretch this by a factor of 3. So it's just going to be 3 absolute x. And I emphasize that so we don't look at it as a 1. So let's do it one more time, but this time compress it vertically by a factor of 1/5. So it's just going to be 1/5 times absolute x. So we see what's going on here with the functions, but what does it look like, as a graph? Well, as a graph it looks like this, and it can be a little bit weird, but follow me here. In black is the cube root of x. Again, centered at 0, 0, going through the point 1, 1, and -1, -1. In green is the stretch vertically by a factor of 3. So 0, 0 stays the same. It all stays centered at 0. But it goes up to 1, 3, which is for every x value, 1, the output is going to be multiplied by the factor. In this case, it was a factor of 3, so 1 times 3 is going to give you 3. So that's why this shifts up, or stretched up 3 units. And this here, -1, -1, is stretched down to -3 because the y value is multiplied by 3. So just consider this just pulled up, stretched up, and this is stretched down. Now in red, it's compressed by a factor of 1/5. So again, still going through 0, 0, but the y value 1 is multiplied by 1/5. So in here they give it as 0.2, but 0.2 is just the decimal approximation of 1/5. Same thing over here. Multiply -1 by 1/5 and we get -0.2. So you kind of look at the original graph in black and imagine just kind of being pushed down, it's compressed down. This is just sandwiched up. Versus in green, the graph in black is stretched up and stretched down. So again, in black is the original function. In green, it's the stretched vertically function by a factor of 3. And in red, it's the compressed vertically by a factor of 1/5.